Every single day, you step into spaces, you live and work beneath roofs, you experience the sheer, well, permanence and ingenuity of buildings.
Hmm.
We often take for granted the shapes, the structures, the very way they stand strong, sometimes for centuries.
Absolutely.
But have you ever really stopped to ponder who truly designs them and how that role, that fundamental definition of an architect, has transformed radically across human history?
It's a really fascinating question.
It's a story of evolution, intellectual leaps, and some truly surprising shifts in status that ripple right through to how we build today.
It is fascinating, isn't it? Because for much of human history, the individual conceptualizing a building was often also the one, with their hands in the mortar, directing the stonecutters, understanding the practicalities of every single joint and beam.
Right. That clear division we see on a modern construction site, the architect with their drawings, the structural engineer with their calculations, the project manager orchestrating it all.
Yeah, and the skilled craft workers actually doing the building.
That whole separation wasn't always the case, was it?
Not at all. For a very long time, these functions were deeply, fundamentally intertwined within what we often call the master builder.
The master builder, okay.
Okay.
And that profound shift, that moment of, let's say, intellectual separation, is exactly what we're diving into today.
Mhm.
We're taking a deep dive back to the vibrant heart of the Renaissance, a truly pivotal era when the very idea of an architect, as we largely understand it, was profoundly redefined.
And the key figure here.
Our main focus is on one monumental figure, a true intellectual giant, Leon Battista Alberti, and his groundbreaking treatise on the art of building.
Right, De Re Edificatoria, a truly foundational text.
So our mission in this deep dive is to unpack how Alberti's revolutionary ideas didn't just, tweak the existing system. They fundamentally separated the act of designing from the craft of building.
Yeah, this wasn't a minor change at all. It established a completely new theoretical and intellectual foundation for architecture, positioning the mind, the intellect, squarely at the forefront of creation.
Okay, so mind over matter, in a sense.
You could sort of put it that way.
Oh.
We'll explore how this conceptual shift not only elevated the architect's status, but also laid the groundwork for the entire modern construction industry.
And we'll look at the benefits, presumably.
Oh, definitely the immense benefits, but also the complex challenges this separation continues to present on job sites around the world, even centuries later. It's a dynamic that's still very much alive.
Okay. So, to guide us through this journey, we'll be drawing insights directly from Alberti's own meticulous words.
Which are remarkably clear, actually.
And from historical architectural texts that beautifully set the stage for his visionary work and the architects who followed him.
Yeah, we need that context.
And crucially, we'll also look at modern project management guides and things like building information modeling guides.
Yeah. Very important today.
Because these contemporary sources will show us just how incredibly complex and sophisticated the relationship between the mind that conceives and the hand that builds has become in our highly specialized world.
It's a fascinating journey, really, that fundamentally changed how we shape our built environment.
So let's get started.
Okay,
let's unpack this Renaissance revolution and Alberti's incredible vision of the architect. But to truly appreciate how radical Alberti's ideas were, how they sort of caused an earthquake in the architectural landscape, we first need to understand the bedrock he was trying to shift. What did architect even mean before he came along?
That's absolutely the perfect place to start. Before Alberti, particularly in the European tradition, Roman architectural theory was, well, it was heavily influenced by Vitruvius.
Vitruvius, everyone points back to him, right?
Pretty much. His 10 books on architecture was the foundational text. It was ancient, sure, but it was seen as the authoritative guide for centuries.
Okay.
Vitruvius, writing way back in the 1st century BCE, he outlined the qualities of a good architect as someone knowledgeable in, everything. Writing, drawing, geometry, history, philosophy, music, even medicine, law, and astronomy.
Wow, a Renaissance man before the Renaissance.
Essentially, yeah. But, crucially, his definition still implied a very hands-on, comprehensive master builder. He talked about firmitas, utilitas, venustas, firmness, utility, and beauty as the 3 essential qualities.
The Vitruvian triad, yeah.
Exactly.
Yeah.
But the means to achieve them were still deeply rooted in practical craft, in the making of things.
Right. So this wasn't just a theoretician sitting in a studio, was it? From what we've seen in historical accounts, like those referenced in, say, the cathedral builders,
Hmm.
the world before Alberti was largely the realm of these master builders. These were individuals who held truly comprehensive knowledge, blurring the lines between the designer and the artisan.
Totally blurred.
They were incredibly hands-on, deeply immersed in the craft of construction. They understood every material, every technique from the ground up, quite literally.
Exactly. Imagine someone who could sketch the initial design, calculate the stresses, maybe even personally select the stone from the quarry.
Right.
Instruct the masons on exactly how to cut it, and then supervise its placement, troubleshooting problems right there on the spot.
That's a huge range of skills in one person.
It is. The master builder was often a singular, authoritative figure, capable of supervising the entire process from initial idea to the final stone being laid. Their understanding wasn't just theoretical, it was experiential, embodied.
Embodied knowledge. I like that.
Yeah, learned through years, even decades of direct physical engagement. It wasn't solely from books, it was learned through apprenticeship, through doing.
Okay, so against that backdrop, enter Leon Battista Alberti.
Right, mid-15th century.
And his masterpiece, On the Art of Building, published posthumously, I think, in 1485.
That's right, he worked on it for decades.
And this wasn't just another commentary on Vitruvius, though it definitely engages with him.
Oh, absolutely. Consciously positions itself in conversation.
But Alberti meticulously set out to update Vitruvius, didn't he? To make his ancient wisdom relevant, even revolutionary, for the booming intellectual and artistic climate of the Renaissance.
Precisely. He wasn't simply transcribing old ideas. He was actively reinterpreting and expanding upon them with a very specific, fundamentally modern purpose in mind: to elevate architecture itself, to give it a proper intellectual footing.
And here's where it gets really interesting. Their profound intellectual shift occurs, right?
This is the core of it, yeah. Alberti posited that an architect's primary tool was not the hammer or the chisel, not even the measuring tape, really.
As it might have been for the master builders.
Exactly. Instead, he argued, the architect's most essential instrument was the intellect itself, the mind.
Wow. That's a radical departure.
It really was a profound redefinition to the profession. Alberti envisioned the architect as a theorist, a scholar, philosopher of form, rather than merely a skilled craftsman or hands-on master builder.
So the emphasis shifts completely to the intellectual aspect.
Right. Design was no longer solely about knowing how to construct. It became about knowing why and what to construct, based on higher, often abstract, principles of beauty, harmony, and proportion.
So the core insight here is that Alberti didn't just propose a new way of working. He fundamentally shifted the value proposition of design itself.
That's a great way to put it.
It moved from being a skilled craft, where mastery was proven by your hands and your physical execution, to an intellectual discipline, where mastery resided in the mind's ability to conceive perfect form, proportion, and order.
Exactly. That's a profound reevaluation of what makes a building truly great, moving it from the realm of just, utility and craft to a high art grounded in philosophy and mathematics.
Okay, so what were these intellectual foundations he championed? You mentioned mathematics.
Heavily. Alberti advocated strongly for the use of mathematical proportion to achieve harmony and beauty in design. This reflects that deep Renaissance ideal, that beauty is intrinsically linked to order, to divine geometry.
Right, the Neoplatonic influence, perhaps?
Very much so. We see in sources like A History of Architecture Settings and Rituals how central geometry was becoming. Even later architects, like Borromini in the Baroque era, were intensely focused on inventing forms based on geometry, symbolism, site constraints.
Constantly reworking plans.
Yeah, constantly reworking plans to achieve that felicitous solution of form and space within an underlying geometry. Alberti really initiated this quest for perfect proportion, believing it was the key to imbuing buildings with inherent beauty and cosmic order.
So beauty wasn't just decoration for him.
No, not at all. He believed beauty was an inherent quality, distinct from ornament, arising from a rational, calculated disposition of all the parts, where nothing could be added or taken away without disrupting the harmony.
And he didn't just stop at abstract mathematical ideals, did he? He brought in the classical orders.
Oh, absolutely. He rigorously emphasized the integration of classical orders: Doric, Ionic, Corinthian.
The big three.
Exactly. But these weren't simply decorative elements to Alberti's. They were an inherent intellectual part of a structure's foundation. They embodied those principles of proportion and harmony.
And we know from history the Greeks established these orders, each with specific proportions, conveying different characters.
Right. Doric being sturdy, Ionic more graceful, Corinthian, very ornate.
And the Romans adopted and adapted them, often preferring the Corinthian, maybe scaling them up for their big public buildings.
Yes, they certainly did. Alberti, in his rigorous update of Vitruvius, wasn't merely admiring these classical forms. He was meticulously defining their application as a matter of universal principle. He saw them as embodying perfect ratios.
Okay, so it gets really specific.
Incredibly specific. He provided precise, mathematically derived parameters for design elements. For instance, he actually dictates, and I'm quoting roughly from his text, the architecture of Leon Battista Alberti. In all openings over which we make arches, we should contrive to have the arch never less than a half circle, with an addition of the seventh part of half its diameter.
Wow. Okay, that is not messing around. That's not just make it look like a nice arch.
Not at all.
Hmm.
It's not about trial and error or just what feels right to the builder. It's about defining its exact mathematically derived proportion. It's almost like a sacred formula for perfect beauty, leaving very little to chance or mere craftsman's intuition.
It transforms arch making from just a craft
Into an intellectual exercise in geometric perfection.
Okay. That precision really drives home the point. The architect's role was moving from an empirical understanding what works through experience to a theoretical understanding what is mathematically perfect and beautiful.
Exactly.
And this intense focus on the intellectual, the mathematical, the classical, this directly elevated the status of the architect, didn't it?
Hugely. It moved them from what we might call a master builder, maybe like the medieval masons we read about in the cathedral builders.
Right. Highly skilled, but perhaps not seen as artists in the same way.
Precisely. It moved them to the status of a respected artist and intellectual, on par with poets, philosophers, the humanist scholars of the day.
So this conceptual shift created a completely new kind of professional, a diseño, a designer.
Yes, the power of diseño, both drawing and intellectual conception. This individual was now responsible for the overall vision of a project, conceiving the form, determining the proportions, ensuring the intellectual and aesthetic coherence of the entire structure.
And crucially, they could do this often from a distance, through drawings, through writings.
That's a key part of it, not necessarily by personally hewing stone or setting bricks or directing every physical aspect on site. The role became one of an overseer of ideas, a purveyor of concepts, much more than a hands-on manager of material.
And that's a critical distinction, because to fully appreciate this new kind of professional and the profound shift Alberti initiated, we really have to understand the world he was consciously moving away from.
Exactly.
A world where that overall vision was deeply physically intertwined with the craftsman's hands and their embodied knowledge. It was a realm of intense hands-on craft.
Deeply integrated, where knowledge of design and execution often resided within one individual or maybe a very closely knit group of highly skilled artisans.
So before Alberti's theoretical separation, this master builder's domain involved a level of direct physical engagement with materials and processes that is, well, it's quite astonishing to us today, isn't it?
It really is. Their expertise wasn't abstract. It was forged through years of practical experience, understanding the nuances of every material, stone, wood, metal, and every tool.
They didn't just know the strength of a beam in theory.
No, they knew the specific feel of cutting a particular type of timber, or the precise heat required to forge a connection, or how a certain stone would cleave.
Let's consider some vivid examples of this intense craftsmanship from around that era, maybe just slightly after Alberti. What about Jorge Agricola's De Re Metallica, published 1556, I think?
Oh, a fantastic example. It offers an incredibly detailed contemporary account of mining and metallurgy. And it's not a theoretical treatise on the idea of smelting.
No, it sounds much more practical.
It's essentially a meticulous instruction manual, almost like a recipe book for metalworking, focusing entirely on the how of making.
So, really detailed.
Astounding in its specificity. Agricola details precise methods for smelting ores, specifying the use of various fluxes, things like lead ash, saltpeter, orpiment, right down to their quantities and how to apply them.
Wow.
He describes the construction of elaborate furnaces, the exact tools needed, rabbles, tongs illustrating their use with detailed woodcuts. He talks about, say, throwing sulfur into melted lead, repeatedly removing the scum until all the lead turns into powder.
Goodness.
Or how lead is flattened into sheets and placed alternately with sulfur in a crucible, heated until the lead turns to ashes. This isn't conceptual design. It's intimately practical, focused on the tangible step-by-step physical process of transforming raw materials.
It's like artisanal chemistry and engineering rolled into one.
Exactly, where knowing the theory, such as it was completely inseparable from knowing the physical manipulation.
It's almost mind-boggling, that level of tactile, iterative mastery. Today, we just assume the separation of thinking from making, but these individuals were the entire process.
Pretty much.
And it wasn't just mining or metallurgy. Think about the precision involved in something like printing, which was also exploding around that time.
Right.
Joseph Moxon's Mechanic Exercises, Volume 1, gives another incredible picture of skilled craft, focusing on type founding. Published later, late 17th century, but reflecting centuries of accumulated artisanal knowledge.
Absolutely. Moxon meticulously describes processes that required immense manual dexterity and constant iterative adjustment.
Like what specifically?
Well, he writes in great detail about filing the punches, justifying the matrices, dressing the sticks to create the actual type.
Yep.
Every single step, from achieving the true fatness of a stem, that's the precise width of a letter's stroke,
Okay, true fatness.
to ensuring letters rub flat halfway up beyond the beard, which describes how the character face is carefully ground to ensure an even impression when printed.
Incredible detail.
It required an artisan to possess an exquisite feel for the material and the tools. He talks about making reiterated proffers with a tiny file to bring a stem to its exact width, or how the depth of sinking a counterpunch affects the letter's final height and breadth.
This really exemplifies the hand in mind and hand, doesn't it?
Absolutely. The intellectual understanding of form and function was utterly inseparable from the physical skill, refined through endless repetition and minute adjustment. The knowledge resided in the fingers as much as in the brain.
Okay. So these examples truly highlight a pre-Alberti era where knowledge of design and execution were often deeply integrated. The person who understood the form of the arch also understood the force required to cut the stone and the skill to lay it correctly.
Precisely.
And Alberti's proposition fundamentally fractured this unity. He consciously separated conceptualization, placing it firmly in the hands of the intellectual architect, distinct from the physical act of building.
And that separation, well, as we'll see, it had profound and lasting consequences. It didn't just change the architect's status. It irrevocably altered the entire structure of how we conceive, plan, and execute building projects today.
A foundational moment.
Truly, a foundational moment that continues to reverberate, shaping our entire construction industry and all the roles within it.
So, what does this all mean for the modern age? Alberti's conceptual separation of design from execution. It had these profound, lasting consequences. It really laid the groundwork for the modern structure of the construction industry as we know it today.
It absolutely did. It ushered in an era of specialization that we now just take for granted.
Right.
This specialization meant that new, distinct roles began to emerge, each focusing on a specific and increasingly complex aspect of building.
Like the structural engineer.
Exactly. Take the structural engineer, for instance.
Yeah.
That role, as a distinct profession, didn't really exist in the same way for the master builder.
No, they'd handle that themselves.
Right. But Fundamentals of Residential Construction clearly defines their modern role as preparing designs specifically for load-bearing structures, ensuring stability and safety through calculation. This is a world away from a single master builder handling all that. Now, it's a dedicated, highly specialized field of expertise.
Okay. And it's not just the structure, is it? We now have this complex web of professionals coordinating all sorts of intricate details.
Oh, definitely. Think about specialized project management. The intricate coordination required in today's projects, whether it's centralized or decentralized, is just immense.
Yeah.
The PMBOK guide, the project management body of knowledge, emphasizes how critical coordinating that collective work effort is. Project teams need continuous engagement with stakeholders, managing communications, resources, risks, across dozens of specialties.
So the project manager becomes this crucial hub.
Absolutely. Their role in orchestrating these many hands and minds, ensuring they're all pulling in the same direction, aligned with the design intent, has become absolutely vital.
So this specialization, which really stems from Alberti's initial conceptual split, it offers some undeniable benefits, right? That's why it's stuck.
Oh, absolutely. It allows us to build structures of unprecedented scale and complexity.
Okay, like what? What are the main benefits?
Well, one of the biggest is certainly efficiency and just deeper expertise. When you have individuals or teams focusing solely on one area, be it structural design, mechanical systems, interior finishes, fire protection, whatever,
Right.
they can develop much deeper, more refined expertise in that specific area. This leads to more innovative, more complex, and often just, well, better refined designs than a single individual could ever possibly achieve.
It's like the difference between a general practitioner doctor and a highly specialized surgeon.
That's a great analogy. That's exactly the kind of specialized expertise we're talking about across various construction disciplines now.
And this naturally extends to quality control, I assume.
Yes, definitely. With defined roles and specialized knowledge, quality control, QC, and quality assurance, QA, can be applied much more systematically. Each specialist is responsible for their domain.
Right.
The CMAA Construction Management Standards of Practice, that's from the Construction Management Association of America, clearly outlines how the construction manager, for instance, monitors contractor compliance with expected quality levels. They might even coordinate field testing that isn't covered by individual contractors.
So it's a more structured approach to ensuring quality.
Exactly. It helps ensure a consistent, high standard across all the intricate aspects of a project, from the concrete mix design right down to the sealant around the windows.
Plus, think about the sheer complexity of modern buildings. They integrate these vast arrays of incredibly sophisticated systems.
Oh yeah, mechanical, electrical, plumbing.
Structural, sustainable technologies, communications, security, fire, safety, the list goes on.
It really does. And this requires a multitude of experts working in concert, not just in isolation. Integrated building design, as described in Sustainable Construction Green Building Design and Delivery, explicitly involves multiple disciplines and seemingly unrelated aspects of design to achieve synergistic benefits.
So you need specialists for everything. Fire extinguishing systems, smoke control.
Specific fire resistances for walls and floors, exit pathway design, accessibility standards, all meticulously detailed in text like Building Codes Illustrated. Each of these aspects requires highly specialized, in-depth knowledge.
It's about safety, functionality, performance.
Exactly. All for the occupants. And this is where granular details become critical. Things you find in guides, like the Builder's Guide to Hot, Dry, and Mixed Dry Climates, or Building Construction Illustrated.
Like what kind of details?
Well, think about the insulation of a building envelope, or the specific design of window framing to optimize daylighting while reducing heat gain, all while trying to meet increasingly stringent energy codes. These are highly specific areas of expertise now. They contribute significantly to the overall performance, comfort, and sustainability of a modern structure. The choices of materials, their thermal properties, how they interact with the climate and the site.
These are all critical design decisions.
Right, and they're now informed by specialists, not just based on a single master builder's intuition or past experience.
But of course, this separation of mind and hand, while offering all these benefits, it must also introduce significant challenges, right? Persistent ones.
Oh, absolutely. That's the other side of the coin. One of the biggest and perhaps most frustrating for everyone involved is the potential for communication breakdown.
The gap between the designer and the builder.
Exactly. There's a constant danger of disconnects between the mind, the architect's conceptual design intent, their vision, and the hand, the actual execution on the job site by various contractors and craft workers.
Can you give an example?
Sure. Imagine an architect envisions a perfectly seamless, minimalist facade. But maybe the builder interprets the detailing differently or uses a slightly different technique, leading to visible joints or a different material texture than intended. It happens all the time.
Or delays.
Oh, definitely delays. A common, very practical example is the approval chain for shop drawings.
Oh, yes, shop drawings.
Construction Management Jumpstart highlights this well. A bottleneck anywhere in that process, say, a designer taking too long to review, or maybe a subcontractor submitting incomplete drawings, can significantly delay work progress on site.
And these drawings are crucial for translating the design.
Absolutely critical. They translate the conceptual design into precise physical reality for fabrication and installation. If they're not understood or approved swiftly and correctly, the whole project can just grind to a halt.
And it's not just about speed, right? It's about clarity in conveying that design intent in the first place.
Precisely. Translating that abstract vision into actionable instructions for builders is where specifications, or specs, become absolutely critical.
Okay, tell me about specs.
Well, construction law gives a good overview. They can be broadly categorized. You have performance specifications, which basically prescribe the desired end result or outcome.
Like, this wall must achieve this fire rating.
Exactly.
Yeah.
It gives the contractor flexibility in how they achieve it. Or you can have work methods or prescriptive specifications, which dictate the exact means and materials to be used.
Like, build the wall using precisely these bricks, this mortar laid in this specific pattern.
Right. And the type of specification used directly impacts the contractor's obligations, their flexibility, their liability. It underscores the delicate balance in communicating design intent effectively and unambiguously.
So getting the specs right is crucial for avoiding disputes.
Hugely important. Moreover, real-world projects are inherently full of uncertainty and risks, as the PMBO guide constantly reminds us.
Yeah, things never go exactly to plan.
Never. Unexpected site conditions, finding rock where you expected soil, for example, material shortages, labor disputes, maybe regulatory changes mid-project. All these can throw the most meticulously planned project off track.
So even the best schedules are vulnerable.
Absolutely. Even the best scheduling efforts can be severely impacted by unexpected problems or changes. This can lead to things like constructive changes, where the owner implicitly directs a change to the contract terms through their actions. Or even acceleration demands, where the owner wants the project finished sooner, maybe despite justified delays, which often leads to increased costs and potential quality issues. Project management in construction discusses these scenarios.
So this inherent variability requires constant adaptation.
Yes, continuous adaptation, robust risk management processes, and constant, clear communication between all parties. It's all about managing that gap between what was designed on paper or on screen and what can realistically be built on the ground.
Okay, this raises an important question then. If Alberti, in a sense, created this fundamental divide, how do we bridge it today? Because we obviously do build complex things successfully.
Right. And thankfully, modern tools and methodologies have emerged specifically to address these challenges and foster collaboration. They're attempting to reintegrate the mind and the hand in sophisticated new ways.
Okay, like what? What are the key tools?
Well, a prime example, and one that has truly revolutionized the industry in the last couple of decades, is building information modeling, or BIM.
BIM. We hear that acronym a lot.
And for good reason.
Yeah.
It's not just a fancy 3D drawing tool, though it includes that. It's fundamentally a digital database that integrates objects, spaces, facility characteristics. It creates a shared, intelligent model of the entire project.
A digital twin, almost.
That's a good way to think of it. As detailed in the BIM handbook and the CMA Construction Management Standards of Practice, it's essentially a virtual prototype of the building before you build the real one.
Okay, and how does BIM specifically help bridge that mind-hand gap?
Well, several ways. First, BIM utilizes 3D parametric modeling. This means design intent is captured parametrically. Think of it like smart Lego bricks.
Okay.
If you change the size or position of one smart element, like a wall, all the connected pieces, beams, ducts, pipes that run through it or attach to it can automatically adjust based on predefined relationships and rules.
Ah, so it maintains consistency automatically.
Exactly. This significantly reduces coordination errors because a change made in one view or by one discipline can propagate intelligently through the entire model, updating everything else. It helps anticipate problems before they become costly on-site mistakes.
That sounds incredibly powerful.
It is, and the capabilities extend far beyond just design visualization.
Hmm.
BIM allows for automated clash detection.
Clash detection, what's that?
The system automatically checks for interferences by searching for intersecting volumes within the model.
Yeah.
This is often done by combining multiple models from different disciplines, structural, mechanical, electrical, plumbing, to identify, for example, where a large HVAC duct might be planned to go right through a primary structural beam.
Which you definitely don't want to discover during construction.
Exactly. This proactive problem solving, identifying conflicts virtually before any concrete is poured or pipe is laid, is invaluable for saving time, money, and a lot of on-site frustration.
I can imagine. What else can BIM do?
Well, you can also leverage 4D schedules.
4D, time as the fourth dimension.
Precisely. It dynamically links critical path method, CPM, schedule activities essentially, the project timeline and key construction steps to the 3D objects in the BIM model.
So you can visualize the construction sequence.
Yes, it creates an animated representation of the construction sequence over time. It's a powerful tool for planning phasing, coordinating work crews, and communicating the plan visually to everyone involved, from high-level stakeholders right down to the craft workers on site.
So you can literally watch the building grow digitally.
You can. And you can run what-if scenarios, identify potential scheduling conflicts or resource bottlenecks long before they become real-world problems.
Okay, that's 4D. You mentioned 5D earlier.
Right, 5D cost management. Every element in the BIM model can have its cost attributes linked to it.
Ah, so automated cost estimation.
Pretty much.
Ah.
It allows for parametric and dynamic quantity takeoffs. If the design changes, the quantities update, and potentially the cost estimate too. This results in far more accurate estimates and frees up estimators to focus more on cost analysis and value engineering rather than tedious manual counting.
And managing all this BIM data requires a specific role.
Often, yes. To manage this increasingly complex BIM process, a specific role, often called the BIM integrator or BIM manager, is frequently assigned. This individual or team oversees the entire BIM workflow, coordinating the model, setting standards. It could be someone within the architect's firm, the engineers, the builders, or even an independent consultant acting as a central hub for all the digital information.
Okay, so BIM is a huge technological leap. Are there other methodologies trying to bridge this gap?
Yes, beyond technology, there are process methodologies like lean production systems, or LPS, which are gaining significant traction in construction.
Lean, like lean manufacturing.
Exactly, adapted for the construction environment. These aim to further align the actions of individuals, both the craft workers actually building on-site and the knowledge workers designing and managing in the office,
How do they do that?
by providing specific functions, principles, and processes focused on optimizing project delivery, reducing waste, and maximizing value.
Okay.
LPS is fundamentally designed to handle the inherent variability and uncertainty in construction. One key aspect is buffer management.
Buffer management.
Yeah, using buffers like capacity buffers, inventory buffers, time buffers, monetary buffers, even spatial buffers on site as mechanisms for absorbing disruptions and preventing errors from propagating throughout the project. The Practitioner's Guide to Essential Lean Research talks about this.
So it's about building resilience into the process.
Exactly. The goal is to structure and manage the production system to facilitate optimal judgments by everyone involved, reducing the dependence on constant replanning and reactive problem solving. It makes the entire process more predictable and collaborative.
More predictable, more collaborative. That sounds like the goal. Which leads us to integrated design, maybe. Is that related?
Very much so. Integrated design, or integrated project delivery, IPD in some forms, is a direct, philosophical, and practical response to the fragmentation created by specialization.
Okay.
This approach emphasizes high-level collaboration and teamwork right from the start. It ensures greater communication among the project team members, as Sustainable Construction puts it, and involves a wide range of stakeholders, architects, engineers, key contractors, sometimes even the owner and facility managers, from the earliest conceptual stages of the project.
So breaking down the silos early on.
Precisely. And it makes a real tangible difference, especially in complex projects like sustainable construction. Well, in sustainable design, integrated design involves specialists from architecture, HVAC, lighting, electrical, landscape design, maybe energy modeling, all working together from the very beginning.
Okay.
This allows them to identify synergistic solutions, things like optimizing a building's orientation and window placement for passive daylighting, while also implementing advanced thermal insulation and maybe demand-driven solar protection, like computer-controlled exterior blinds.
All working together to minimize energy loads.
Exactly. It brings the intellectual rigor of design together with the practical implications of construction and operation in a holistic, mutually reinforcing manner. It's essentially trying to consciously close that Alberti-created gap through intense, early structured collaboration.
So if we look at the architect today, we can clearly see a profound legacy of Alberti's vision, can't we? Even after all these centuries.
Oh, absolutely. That 15th century redefinition of roles Alberti spearheaded continues to shape the fundamental relationship between architects and builders globally.
The architect remains, in essence, the visionary,
Right.
the intellectual guide.
Yes, the conceiver of form and space. That core idea persists. But now, they operate within this highly complex, multi-layered system.
A system that's evolved specifically to manage the separation.
Precisely. A system designed to manage the very separation Alberti initiated. It's no longer just a single mind overseeing everything, but a coordinated effort of many specialized minds, all working towards a common goal defined initially by the architect.
So the architect sets the intellectual framework.
Right. But a vast team of specialists translates, refines, and executes that vision using sophisticated tools like BIM and processes like lean and integrated design to try and maintain coherence across that mind-hand divide.
So the journey of a building, from just an abstract concept in the architect's mind, maybe a sketch, to a tangible physical structure standing on a job site, truly requires this intricate dance between theory and practice, between intellect and craft.
It's a constant negotiation, isn't it? A sophisticated collaboration that has been refined, certainly complicated, but also made more efficient over centuries, all tracing back, in many ways, to that fundamental shift Alberti instigated during the Renaissance.
We've covered a tremendous amount of ground today. We've seen how Leon Battista Alberti, with his profound emphasis on intellect, mathematical proportion, the rigorous application of classical orders, he didn't just write a book.
No, much more than that.
He essentially invented the idea of the architect as a distinct intellectual professional as we largely know it today.
Yeah, shaping the profession's trajectory for centuries.
And this was a conscious, deliberate move to update Vitruvius for a new humanist age, fundamentally separating the act of designing from the craft of building.
And from the intensely hands-on world of the medieval masons and master builders, through Alberti's intellectual revolution, to today's incredibly complex landscape of BIM, lean construction, integrated design. That dynamic tension and the essential collaboration between the mind that conceives and the hand that builds remain absolutely central to bringing architectural visions to life.
It's a powerful testament, really, to the enduring impact of ideas on our built environment, shaping not just how we construct, but how we even think about construction itself.
Absolutely.
So as we wrap up this deep dive, it leaves us with a provocative thought, maybe something for you, the listener, to ponder. What does this all mean for the future? As digital fabrication, things like 3D printing on a large scale and artificial intelligence continue to evolve, allowing for increasing levels of personal and even community self-sufficiency in making things. Authors like Neil Gershenfeld explore this in Designing Reality.
Democratization of making.
Exactly. Will the pendulum swing back? Could the gap between design and execution, the mind and the hand, actually shrink once again?
That's a fascinating question.
Perhaps this could lead to new forms of master builder, maybe digitally enabled ones, where the sophisticated tools of the intellect and the direct means of production are once more integrated, but in entirely novel, technologically advanced ways.
A sort of neo-master builder.
Maybe. It raises an important question about how we will continue to define architecture and building in an ever-evolving technological landscape. What will the architect of tomorrow look like, and what new roles, or perhaps reintegrated roles, will emerge from all this?
It certainly makes you think about where things might be headed.
It does indeed. That's a fascinating thought to ponder. Thank you for joining us on this deep dive into the very foundations of modern architecture.
My pleasure.
We'll see you next time.